Welcome to the Accenture Innovation Center in Essen. Today we would like to introduce you to Geographic Information Systems. So how they can be used to aggregate information from different sources and visualize them in the contextual geographic map view that then can overlay multiple information sources. As an example, today we will show the software ArcGIS, at first with the cloud solution and then afterwards with the ArcGIS Enterprise, where we show a special utilities solution. The first example is using ArcGIS Cloud. And the example here is a big project, a so-called linear project. The company is building an underground high voltage DC cable from the north of Germany to the south. And with this example, we want to showcase how in such a very big project with hundreds or even thousands of contractors, you can use a system like ArcGIS or other GIS system to aggregate data that is usually hidden in many different local or regional or basically separated systems. The starting point for all of this is a map. And on this map I can overlay different information and convey information or data or project status to a large number of users. They all just need the web browser or the ArcGIS app. So here in this example, we are close to Hamburg. We have the different sections of the project. So this is going all the way to the south. And along the sections, I have the subsections. And I can see here already where the future cable will be potentially laid. So this is just a draft at the moment. And so planners can then directly go into the different sections and then see, for example, where there's the cable, the different subsections, what's the status of the cable, is it planned, is it the final location, is it an early status, what's the specs of the cable. We've put in only a few examples here. The list is much bigger, but we were relying in this case on publicly available data that we can share, because of course we cannot show you any client project. So we took in, for this example, data that we could download from the internet for this project, because they have to publish it. And I can see all the elements. So this is each segment of the cable. There's the cable joints. They all have unique names. And I can see then where they will be laid. And I can also, when I'm in the field, for example, negotiations with the farmer, I can see exactly where the cable will be located and can discuss with them the implications. I can also see satellite imaging to see if the cable is probably going through a house or something, which of course doesn't work. So this is very interesting for the planners in the headquarter, and of course also on the field when they discuss it with the different stakeholders along the cable route. When the project continues, we can then also put in the status, and it's a bit flickering here, that's really weird, with the status of the project. So in this case, we are taking from the project plan the information, what's, for example, the percentage of the length of the cable that has been already laid in this segment. This is, simply speaking, a table with the status of the segment, here shown as an overlay and even as with color coding in the GIS system. So we basically can transport any structured information, which usually is stored in a table, and showcase it here as graphics, visualizations that we can put in layers and put them over each other. I can also add then buildings. For example, there is here this, there's under the river here, there will be an underwater segment, and there's a building here where the river crossing is ending. And these elements could be then linked here. I could theoretically link it directly with pictures of it. I could could put the URL in there, which directly leads me to the asset documentation or the 3D model of the building. Again, this is just used if you are searching for something, if you need more information, contextual information, that you can, from the map, directly go to the detailed information. I can also take information in here. For example, this is mock-up data, and so we have then here the information of the land plots along the line. So which land plots do I need to buy? What's the status of the land plots? Did I already acquire it? And so on and so on. I can visualize this. And again, the people in the field that do probably the negotiations with the farmers, with the cities or whatever, that own the plots of land along the route of the cable, they can use this for the negotiations directly on the site. And they always have access to the probably almost real-time data that would be otherwise, again, hidden somewhere else in other systems. I can also, for the planners, I can add information. Where are there protected zones along the way? For example, natural habitats, water protection areas. So I can see, for example, here that this planned route would go through an environmental protected area. The Lüneburger Heide in this case, so that's probably not possible, or it will require additional planning and negotiations and discussions with the environmental agencies. So again, just the visualization, data is available somewhere else, but it really helps to have all of this together in one system that you can use with a layered view to add this information over the map. The next example is how a GIS system like ArcGIS can be used in daily operations. And we again use demo data here because we cannot show you client data. The demo data is coming from a city in North America, Naperville. In the top left corner you can see a circle. And this circle is the largest particle accelerator in North America. And this is, of course, a very perfect location because there's lots of universities and other facilities there, and they need a lot of power. So this example shows the entire electric grid. So all the substations that are supplying the area, you can see all the power cables, and it goes down to the very extreme detail level of even the housing level. So I can zoom in whenever I want and look down from the top level of the distribution grid down to the local cables, even between the houses. Why do I want to do that? It's a full asset documentation. So when there's a problem, if I want to do installations, if I want to do an update, I can directly go into this overview. Every worker can do that and can see the status of the different switches along the way. Has the client paid, for example? Is the house connection switched on, switched off? What's the status of my distribution network? I have all of this more or less in real time available directly in the system. And again, this helps that you avoid using half a dozen different systems that have the asset documentation. This is, from a detail perspective, really amazing, and we actually have sometimes really almost performance problems with our GIS server because of the absolutely massive level of detail, because you can really go down to the level of the lawn of each customer to see where the cable has been laid and where, for house, for example, all the master data that is usually coming from SAP or from the SCADA system, all the status information can be shown. This is not really real-time information. It's updated a bit infrequently, but it's mostly showing really up-to-date data. Yeah? The update frequency can be altered to whatever you want, but of course, if you have such a very complex grid with so many nodes of information, this gets really tough to get this all together in one system and still have a good performance. I hope this was helpful for you to show here the power of GIS systems. We all know this from, let's say, Google Maps as an example, where we check out if there's what the status of a motorway is and if there's a traffic jam and so on. Now imagine you can use the same power to see the status of your projects, the status of your utilities grid in this example, could be also the pipelines that you have. Is the what you can see the inventory levels along on the area, all on a geo-referenced basis, so that you can see it all on the map, and then have these different types of information all combined in this view as layers, and you can then simply switch on and switch off these different layers to have a better view. And this at a very large scale, because some of these systems, especially in this example with ArcGIS, this can scale amazingly if you, for example, go into the cloud edition. It has its limitations regarding features, but the scaling in the number of users potentially possible and parallel is really amazing. Thank you so much for watching this video. If you are interested to learn more, we welcome you to the Essen Innovation Center of Accenture in the Zeche Zollverein in Essen in Germany. The description with the contact details can be found below.